Okay, so hello to the Python meeting. First question: is there anyone who does not understand German?
Understand German.
Okay, so then we'll. Yeah, understanding Metaclasses. First of all, me, I'm a computer science student at TU Berlin. I work at the Charité University in Berlin. I'm a software developer, doing mostly Django stuff. And I'm involved in a couple of open source projects. I've been doing Python for quite some time, and well, after a while you get across advanced topics like metaclasses, as we're doing today. But the interesting thing about metaclasses is that, unlike other advanced things in Python, like decorators maybe, or generators, they're not really a separate feature. Like, you can take decorators away from Python, and it's annoying, but you can live without them. But meta classes, you can't really remove them. They're a fundamental part of the object system and how it works. And you can see that they really emerge from the basic rules of the object system when you look at them. And to see that it is, let's first ask a basic question. What is an object? Does anyone know?
Instance of a class.
Okay, yeah, that's one answer.
Yes,
But like, what is an object? Like, if I want to test it, what is an object?
an entity where you can call methods on.
Yeah, but like none is also an object, right? Does not have any methods.
Statement, behavior, and message passing, reaction to it.
Yeah, but like, let's think more of the case, like, how do I test if something is an object? If I want to test it in one line, what makes objects? How do I test that in Python?
It's an instance of a class. It means it's code and data.
I can't think of an object.
I haven't seen an object yet, but it's like, is a pass keyword an object? Or an operator? No.
No.
So what is the most fundamental thing I can do with objects? What makes them interesting?
Graph is list. List is an object.
Yeah. I can reference them.
Oh.
All objects, I can put them on the right hand of the assignment. It's like the most simplest way to test if something is an object. If I want to try it out, I simply write an assignment, put it on the right side. It's an object. Everything I can give a name, I can reference somehow. All these things are objects. Just next to it, what is an instance? Like, we kind of touched on that. Like, some people said like an object is an instance of a class. But are there any instances that are not objects? Or is there any difference? Okay. No, there isn't. Like, exactly the same thing. There's no difference. It's not just the word we use to make it clear what something is when you're talking about it. Like, in the case of, it's an instance of some class. We do that to be more precise in our language, but it's not real. It has no really difference. There's no difference semantically. And so what is a class? Well, classes describe objects, they describe instances, but they are also themselves objects. And this is kind of interesting because, as we just learned, instances are also objects. All objects are instances. So classes, being objects, also have to be instances. But of what? And so, and this offers a more interesting problem. Like, if I have a class that's called foo, what if that has to be an instance of some class, and that class too has to be some instance of some other class, and we can continue that indefinitely. And this is solved through metaclasses, and well, fundamentally it's solved through type, which is a special class that is the superclass of all metaclasses, and happens to be an instance of itself, which is, well, probably weird and a little bit magical, and only achievable in the interpreter itself. It's not something you can produce within Python code, no matter how much magic you use. So, with that said, knowing what a metaclass is, how do we affect classes through metaclasses? And the first interesting question is, like, if Metaclass is just a regular class, how does an instance attribute on a metaclass affect my class? Does anyone know? Like, if a metaclass has an instance attribute on the class, on that metaclass, on instances of that class, how does that?
Doesn't affect.
No, it does affect them. They're class attributes.
Can you speak a little louder?
They're class attributes. If I have a metaclass and I define an instance attribute on the metaclass, it acts as a class attribute on classes who belong to that metaclass. Because these classes are instances of that class. It's important to get that right, to understand how, what the relationships are there. Like metaclasses, classes are just instances of some metaclass, and so an instance attribute on a metaclass acts like a normal, a class attribute on that class. Class attributes are just instance attributes just on the metaclass. And how is this different from a class attribute? Well, it's not really. It's just more complicated to define class attributes this way, using metaclass. But most of the time, it's not something you're going to do unless you already are using the metaclass for something else, like defining a method in a metaclass, which brings an interesting question, like what does that correspond to?
If I remember correctly, you can define, for example, operators and metaclasses that then work as on classes, because the classes are the instances of the metaclass, so you can add two classes together.
That is one option. But is there any other way to get the same effect of defining a method in a metaclass on a class? Class methods. As like a class method is pretty much the same, except for a few special methods, which I cannot define within the class itself. Because the class method, or the class method decorator, uses the descriptor protocol. So basically, if you have some kind of object, and that object defines either one of the underscore get, underscore set, or delete methods. With these methods, I can change how Python acts when I set, delete, or get an attribute. And so class methods in Python are usually implemented really just as descriptors. So the get method of the descriptor that wraps the method returns not just the method itself, but a special object that calls my method with a class, no matter how it's called. And with that being said, is there anything unique to metaclasses? Is there anything I can do with metaclasses that I can't do any other way? And yeah, there is. And this is really where, well, obviously, it gets interesting. Most importantly, it gets interesting with these methods, new and init. I'm using Python 3 here. The signature is different in Python 2. Specifically, in Python 2, does not have these keyword arguments. You can pass to classes in Python 3. So you can example how that works. Somewhere? No. So in Python 3, I can define a class, and I can give it some meta class that hopefully treats these, and I can pass here arguments to the meta class, like foo equals 1. And the meta class can then do something with that argument, which is a new feature introduced with Python 3. It's not really used that much yet, for obvious reasons. But this is one of those features, things you can use with meta classes in kind of Python 2. Anyway, what new and init do, or what they're called, is they construct an instance of a meta class, or well, they're called after the body of a class statement is executed. Name here in this case is the name of the class. Basis is a tuple of the classes I inherit from. And namespace is a namespace I defined for everything in the body. So my class attributes will be in there, methods, or at that point they're still functions. And what's interesting in these methods, what makes them interesting, is that I can completely change what class will be produced. I can introduce new attributes, I can remove some, I can perform like some operation on them, and most of the time when you see metaclasses in practice, these will be the methods that I implemented. For example, if you have a form library, what you're going to do is you're probably going to look through the attributes and gives them or makes them aware of the name you've given them when assigning them the body of the class. Or like in an ORM, where you have like a class that represents a model, you might have an attribute like name gleich equals the name column, which represents the name of something, and you assign the name of the attribute to that column instead to in the meta class, so that you don't have to write it by yourself in the code to remove the redundancy. However, in the past this has been much more interesting. Nowadays, I think since Python 2.7, you can use decorators on classes. So with decorators, you can pretty much get the same behavior by modifying this class. And if you didn't know that, you can modify which classes the class inherits from at runtime after it has been created. So you can do pretty much everything you want in a class decorator. The differences here, obviously, you have to use them explicitly yourself. And in some cases, that's really not what you want. Like, you do not want to have the users of your ORM decorate every model with a decorator, or most of the time you don't. And so metaclasses, in this way, are beneficial because they allow you to hide a lot of what's going on behind the scenes, allow you to hide what you want to achieve without exposing anything to the user and showing them what kind of magic you're doing. Which brings us to another interesting method. This is introduced in Python 3.4. Now, before it was new in init, I mentioned that you get the namespace you defined. Prepare allows you to define the namespace. Like usually, when you have a function or anything in Python, the scope, the local variables, will be stored in a dictionary. Or most of the time, there will be. Functions, it's actually said differently, but most of the time this will be the case. But since Python 3 was in classes, you can change that. Instead of using a dictionary in prepare, you can return any kind of mapping, so anything that implements get item, set item, and down item, and return that. And Python will use that instead of a dictionary within the body of the class. And this allows you, for example, to use something like a default dict. So names that would raise a name error elsewhere will suddenly default to whatever the default dict produces. You could return an order dict, which is the reason most people wanted that feature, because with an order dict, you retain the order in which you define attributes in the body of the class, which is interesting for form libraries, where you want to preserve the order of the fields defined. Which nowadays, which currently most libraries, what they do is have a global counter and increment them. And in like a new method of meta class, they walk through all attributes, look at these attributes, this counter, and sort them. And prepare would be a way to make this more clean. But there's also a lot of other interesting things you might be able to do with completely change how namespacing works there. within classes. And that's an interesting thing about metaclasses is a call method. So when you create an instance of a class, when you learn Python, what you learn is that maybe init gets called. If you learn a little bit more, you learn that first there's some kind of new method that gets called, and after that init gets called somehow. But what really happens if you define a class is that the metaclass's call method gets called. And this call method does everything like constructing a class. So to give you an example what they're actually doing. So by default, Python is basically this. It creates a new instance with new. It initializes this instance and returns it. And this is something you can re-implement on your own, or you can do something completely different in a meta class. It is not set in stone how Python constructs classes. You're free to change it completely, which can be interesting and useful, but you also have to be very careful with, because it changes a lot of the assumptions people make about how meta classes work. However, I talked a little bit about how you can use meta classes to hide a lot of things from users. When you use them, you have to be very careful of how users are going to use the classes, because there are some weird scenarios in which meta classes really expose themselves if you're not careful, like inheritance. To give you an example, let's say we have two classes, foo and bar, both with their own meta class. Now what happens if we create a class, let's call it bars, and in that class we inherit from foo and bar. Now bar is an instance of bar meta, foo is an instance of foo meta, but what is bars meta going to be an instance of? There's no really good decision to be made here. So what Python does is, if you define such a class, is it's simply going to raise an exception and going to complain about two meta classes that don't fit together. And this is a big problem about meta classes, because what it means is that you can never introduce a meta class into a class. Like if you have a library or something and you introduce a meta class, it's going to break backwards compatibility with every user of that class who could possibly have used that in combination with some other meta class. And so what you have to do to resolve this is you have to create a new meta class that inherits from the meta classes of the classes you want to inherit from. And unfortunately, if you do not know exactly how they're implemented, this is probably not going to turn out well. So this is probably the biggest problem with meta classes in practice, that they are not at all composable. And it's one of the reasons why a lot of people use them, and why it's a little bit difficult to figure out how they work. And nevertheless, they are used in practice. And most of the time, what they ask is from libraries, ORMs, and well, anything else declarative of some form. So if you look at, for example, Django, where you have like this meta pattern, where you have like a class and define options with a meta class inside. So this is something that Django uses meta classes for, to set defaults and retrieve options from that class. It's also used usually in ORMs to compile metadata structures, where you get information out of the class about what the schema is you define, and it collects them all to create actually tables, or to figure out what other column types and so on. In form libraries, you use metaclasses to figure out in which order or which fields you define, in which order you define them, to figure out for rendering, like in which order we need to render these fields again, and possibly in which order we want to validate them. Yeah. Any questions?
Would it be easy for you to show us an example of Django using metaclasses?
Sure. So, this entire, yes, so this class, model base, is a base class, the base meta class used for all models. And as you can see, this, as expected, you're going to find a new method here. In this case, it does not have this keyword arguments thing, because in Python 2, you can't use it when not available. And what Django does here is it first figures out if it's a subclass or not of model. If it's not a model, if it's not a subclass, it bears out. And after that, it does quite a bit of magic to figure out the state of where the class is defined. It looks up, as I mentioned, the meta module, the meta class you may have defined within the model for options. It figures out where the app is, and possibly wants you, if app label is missing, it adds, Django specifically adds dynamically created classes for things like does not exist, or multiple objects returns exceptions. And well, as you can see, yes. Okay, probably about 100 lines long is this method. Probably not the best example of design.
Well, I guess it's a real world example, right? So, I mean,
yeah, but
they're
you
doing a lot of stuff.
I mean, you could implement this in multiple methods with explanatory names.
That's
you should be doing, like, so, don't do this if you're writing code. Don't write more code than fits on a page, on a screen, okay, on the screen stuff. But yeah, you see here it also figures out like relations between fields and stuff. So pretty much everything you need to know about a model after it's defined, all of that is figured out in metaclasses in Django. Yeah, so that would be an example. But I think Flatland, as for example, is a form library that also uses metaclass. It's a little bit simpler. Where here's an example where they just figure out what the members are, declared, sets the appropriate names, and creates this field schema, which is just a data structure that describes which fields you've defined for your form. And once the forms does something also similar, where actually Douglas call. So when you in metaclass that you use lots of forms, it binds fields to an instance of the form in call, so it doesn't have to do that in init or new of the form class itself, and can do that before actually any indentation happens for caching of that data. Okay.
Do you have an example for prepare in Python 2.3, 3.4, sorry? Because I implemented this with a global counter a couple of times myself, so I'm eager to learn something.
This is
how I can do this
some example. So you need some kind of class that implements get item, set item, and that item. And in prepare is simply return an instance of that class. And in new, you have to be careful. You can't pass that namespace class onto type. Onto the superclass new, you have to pass a dictionary on there. So I do that in new. And here's a simple class that uses that, where we define a foo attribute, we get it somehow, delete it. And if you execute that code now, you'll see in the 3 lines below, exactly in the order in which we deliver in the class body, this will be defined. You also see a couple of other attributes added, like name, which will retrieve. The module is set main because that's so like because we're executing that model currently. And a core name, which is I think also new with Python 3 or 2.7 or something, which would include the name of the module if it would be something different than main. But you could, usual thing would be just to in prepare here. You could just return, for example, autodict, and then you would have get all attributes here in namespace would be an autodict, and you would get the order in which you're going to find in the body. So it's kind of like it executes the code in that namespace.
Can you show the code again? So if I wanted to have the attributes ordered the same way, then self values would be just a
return an autodict here.
Okay.
You just do collections or autodict and return that, and Python would use that. And it's guaranteed that Python, it has to store attributes in the order in which I execute the code.
Yeah.
It's like it takes the code, the body of the class, and executes that in the namespace base you defined.
Yeah, I just was somehow confused how this implementation should return this in some declaration order, because I didn't see it. But
Yeah.
this is a replace namespace with order dict and all of this.
Yeah, but namespace is just an example that can be.
Sure.
It does not have to be a subclass of dict. Any class will do that implements.
It should be dict-like,
that's
right? So the
exactly.
dict protocol.
Yeah. Well, even items and stuff you don't need to do that. You don't even need to all of these methods. As I'm not quite sure what happens if you need one of them off, probably an exception. There we go.
Can you say anything about the differences between using meta classes and class decorators?
Yeah, okay, so a meta class is inherited, which is pretty much the biggest difference. So if you have a class and you define a meta class on that, all subclasses will also be instances of that meta class. They will also inherit that meta class. Class decorator is applied only once, like a function decorator. And so subclasses...
It returns a new object, not a
exactly, yeah. So decorator returns a new class, or the same class just modified. But the decorator will not be applied to subclasses. And maybe that does not matter. But in a lot of cases, with meta classes, it does matter. You want them to apply to every class in the hierarchy. And especially if you want to hide that fact, or if you really want to enforce that and then want to make it optional, class decorators are convenient. And also you can't use class decorators in Python 2.6 to still care about that. So in that case, you're forced to use meta classes instead.